on this video we are going to cover the particular solution when the q of x happens to be a sine or cosine. Okay, so let's assume it is going to be the sine of 2x, something simple. Okay? Okay, the homogeneous solution is still the same, so we haven't changed this part. What I have changed is just the q of x. So my homogeneous solution is still c1 exponential of minus x plus c2 exponential of 3x. Okay, I think it's upside down, but it's still the same. Now, the particular solution, I want to focus on the particular solution. So, the particular solution must be something similar to my q of x, okay? Because I see a sine, I'm not going to propose exponential of 3x, or I'm not going to propose x squared plus bx plus c, because that's a polynomial. So what I'm going to do is propose something similar to the sine of 2x, and when I say something similar, including the 2x. Okay, so the particular solution will be something like this: a sine of 2x. Okay, so it's the same trigonometric function and the same argument. Okay, now we have something here. When you have sine or the cosine, you have to propose the sine, but also you have to include the cosine of 2x. Now, what is the reason of including the cosine? Because the derivative of the cosine happens to be the sine, and here you have derivatives. Okay, so as a rule, whenever you have the sine, you have to propose the sine, but also the cosine. Okay, so let me write down in sine or cosine, you shall write both in the particular solution. So here we don't have cosine, but you have to write it. And again, the reason is the derivative of the cosine is the sine of 2x. So, and here we have derivative. So it's highly possible that the cosine is also in the particular solution, and we have to propose both of them, and with different coefficient, right? Because it could be different. Okay, now the procedure is still the same. We are going to replace this in the differential equation. To do so, we have to find the particular solution derivative, first derivative, and the second derivative. Okay, so let's do it. Let me write here the derivative, the first derivative. So it's going to be derivative of the sine is the cosine, but times derivative of this 2x, that generates a 2. So it's going to be 2a cosine of 2x. Now derivative of the cosine is minus the sine times derivative of 2x. If we use the chain rule for the derivative, so it's going to be minus 2b the sine of 2x. Now remember, this 2 comes from the derivative of the argument. Okay? Okay, so that is the first derivative. And the second derivative? The second derivative is derivative again of this. Derivative of this cosine is minus the sine times derivative of this 2x, that generates another 2, so that becomes minus 4a cosine of, no, sorry, sine of 2x, okay? Now derivative of this sine is the cosine times derivative of this 2x, that is another 2, so that becomes minus 4b sine of 2x. Okay, so let's replace in the differential equation. So here you have the second derivative. I'm going to take from here. Okay, so that is my second derivative. And then minus 2, the first derivative, minus 2, the first derivative, this number, 2a cosine of 2x minus 2b sine of 2x. So that is the particular solution first derivative, and then minus 3, I don't have a space, so I'm going to write it here. I'm going to continue here, minus 3, the particular solution, and the particular solution is this a sine of 2x plus b cosine of 2x. Okay, and then this shall be equal to sine of 2x. And this is my particular solution. Now, let's factorize the common factors. Okay, so I see here the sine, and the sine of 2x. So let's factorize those. And the factorization goes like this. Minus 4a, and then here, minus and minus, minus 4a. Sorry, no. So this is the cosine. Oh, I'm factorizing the sine, so it's going to be minus 4b, and then this a minus 3a, both sine of 2x, and then plus. Now I'm going to factorize the cosine. The cosine is, sorry, here I have a mistake. This is the cosine. Sorry, this is the cosine. The cosine of 2x. Derivative of this minus derivative of the sine is the cosine. Sorry, my mistake there. Okay, so I'm going to factorize this, and this. Okay, so the factorization, the result of the factorization is minus 4b, and then from here minus 4a, and then here is going to be minus 3 times b, minus 3b cosine of 2x, and this should be equal to the sine of 2x. Okay, so what we have to do is make equal the coefficient. So this coefficient must be equal to this coefficient. Now, the other coefficient must be equal to what? Okay, let me write the first coefficient. The first coefficient is minus 4a minus 3a is going to be minus 7a minus 4b, and that should be equal to 1. But what about the other one? Because we don't have a cosine, then this number shall be equal to 0. So minus 4b and minus 3 minus 7b minus 4a equal to 0. Okay? Because we don't have the cosine, or what we can do is write the cosine, but with a 0 coefficient, cosine of 2x. So the coefficient must be equal to 0, while this coefficient is equal to 1. Okay, so from here we have two equations with two variables, and again the task is to find the values of a and b. Okay, so let's clear the value of a here. A happens to be minus 7 over 4b, and let's replace the value of b here, so it's going to be minus 7 times the value of a minus 7 over 4b minus 4b equals 1. This is 4. So this becomes 49 over 4 b. And let's factorize the b. If we factorize the b, it's going to be minus 4b equal to 1. Now let's convert this 4 in fourths. So it's going to be 16 over 4. So 49 minus 16. Okay. 33. So this is 33 over 4b equal to 1. So b is equal to 4 over 33. So the value of a, so we got the value of b, and the value of a happens to be minus 7 over 4 times 4 over 33. So the 4 cancels, and the value of a is minus 7 over 33. Okay, we have calculated the values of a and b. So my particular solution is going to be minus 7 over 33. This is the particular solution. sine of 2x, and then plus 4 over 33 cosine of 2x, and the general solution then is the combination of the homogeneous plus the particular. The homogeneous is c1 exponential of minus x plus c2 exponential of 3x. Is that correct? Yeah. Plus minus 7 over 33 sine of 2x plus 4 over 33 cosine of 2x, and that is the solution, the homogeneous plus your particular solution with the method of undetermined coefficients. Alright? Okay, so that's when you have the sine and the cosine. Now, for this method to work, this is very limited method, because this only works as long, this method of determined coefficients, this only works as long as the q of x is either the polynomial, is exponential, or it is a sine or cosine. So if you happen to have something different, like a natural logarithm, then the method doesn't work. So it is limited, this method is limited to only sine, cosine, exponential, and polynomials. That's it. Okay. Okay. Before we finish this this video, I'm going to erase this part because I want to tell you something that is called superposition. We can superimpose the solution. So imagine that I'm going to clear this. I'm going to need more space here. Let's recover the other examples. In the previous examples, we have a polynomial, and then we have an exponential, and then the sine and the cosine, only the sine. But imagine that you have this differential equation, but it is composed by the 3. So let's assume that it is sine of 2x plus 4x minus 5, and then plus exponential of 2x plus exponential of 5x. Imagine that you have that as the problem. Okay, so your particular solution, the proposed particular solution, will be something like this. In the superposition, the particular solution is going to be something similar to the polynomial here, something similar to the polynomial, something similar to the exponential, and something similar to the sine and the cosine. Alright? So you have 3 types in the same differential equation. And the particular solution will be something like this. For the sine, it will be a sine of 2x. And because you have the sine, you have to write also the cosine, b cosine of 2x. So that is for the sine and cosine. Okay, now for the polynomial, it's going to be ab cx plus d, that is the polynomial of degree 1, and then you have the exponential, so it's going to be c a b c d e exponential of 2x plus f exponential of 5x. Okay, maybe you recall this from the previous videos. This was my first example, this was my second example, and this is this example. So because we have already done each one of them, then we can write the particular solution. Because we have already calculated the values of a, b, c, d, e, and f, then my particular solution, this one is already there, minus 7 over 33 sine of 2x, plus 4 over 33 cosine of 2x, plus here, from the previous video, the result was minus 4 over 3 x, and then minus 7 over 9, and that's it. And then the result of this was minus 1 over 3 exponential of 2x, and then plus 1 over 12 exponential of 5x. Okay, so that is the long answer. If I try to do this here, I don't have enough space to finish it. My point here is that you can, because you have different types, the sine, the polynomial, and the exponential, you can do it separately. You can do this, you resolve it. You can do this in another part, and then you can do that in another part, and then just bring together in a single solution. That is called superposition of solutions. Okay, this part of the solution, this part of the solution, and this part of the solution. Just let me divide the part of the solution now. Why we can do this? The reason why we can do this is because the differential equation is a linear differential equation. Okay? Because it is linear, then we can do it separately and then bring together each one of the pieces. It is the same if you make this procedure all together or you do it separately. Why we can do that? Because it's a linear differential equation. Okay? Okay, now on the next video we are going to cover what to do when you have a combination of the sine and the cosine, sine and polynomial, sine and exponential, and so on. I'm going just to make a table of examples on how to propose a particular solution. I'm not going to solve it, but just making the example. See you in the next video.